Example 27, a hydraulic jump occurs in a transparent closed conduit with the diamond-shaped cross-section shown in the figure. The conduit is horizontal, and the water depth just upstream is 0.6 meter. The conduit is completely full of water downstream of the jump. Pressure gauge readings are as shown in the figure. So first question, compute the flow rate considering head loss but ignoring shear forces along the boundary. Of course, there is supposedly head loss in the jump after the jump because of turbulence. Determine the horsepower dissipated in the jump. So this is horsepower lost or horsepower dissipated. So this is the figure to help analyze. So area 1 is just half of this diamond shape, so it is 0.5 or 1/2 of 0.9 times 0.6. This is the pressure diagram, hydrostatic pressure diagram at 1. The hydrostatic pressure diagram at 2 is not triangular anymore because at 1 the pressure is 0, so here there is 6.9, so it is trapezoidal as shown. So F2. Then this is the supposedly shear stress along the boundary, but it is ignored in this situation here. So area 1 is 1/2 or 0.5 of 0.9 by 0.6. Half only, so 0.6, so 0.27. Area 2 is times 2, so 0.54 square meter. So F1 is specific weight, barred H of the diamond shape is 1/3 of 0.6. So this is 1/3. If this is the triangle, so 1/3 of 0.6. Then area 1 is 0.27, so 529.7 newtons. While F2 is pressure at centroid times area 2. Because there is pressure here. So 6,900 pascals plus 9,810 times 0.6 to the centroid of area 2. That's 0.6. So that's the pressure at the centroid. Then area 2 is 0.54. So F2 is 6,904 newtons. Then equation of summation forces X. By the way, by continuity equation to relate V2 with V1, area 1 V1 equals area 2 V2, so V sub 2 is 0.5 of V1. Then summation forces X equals Q rho quantity V2X minus V1X, although this is also by hydraulic jump formula, general. So F1 minus F2 minus 0 equals Q density V2X, which is 0.5 of V1, minus V1X, which is V1. So F1 529.7 minus F2 6904 minus shear 40 or ignored equals Q density quantity V2X 0.5 of V1 minus V1X, which is just V1. Simplifying, negative 6374.3 equals negative 500 of Q. This is negative 500 Q. Then this is V1. V1 is Q over area 1. So from here we can now compute Q. 1.855 cubic meters per second. Then energy equation between 1 and 2 considering head loss. So we have V1 1.855 Q over area 1 6.870 meters per second. V2 Q 1.855 over area 2 or 0.5 of V1 3.45 meters per second. Then energy equation, velocity head at 1 6.87 square over 19.62 plus pressure head at 1 0, elevation head 0.6, datum at the floor equals velocity head at 2 3.435 square over 19.62. Pressure head is 6.9 kilopascals over 9.81, specific weight of water. Elevation head 1.2. Then plus head loss in the jump. So computing for the head loss in the jump, it is equal to 0.5008 meter. Then the horsepower or horsepower dissipated in the jump is weight flow rate Q times specific weight times head loss in the jump divided by 0.746 if we use gamma 9.81 for water. So Q 1.855, gamma of water 9.81 kilonewtons per cubic meter, head loss 0.5008 divided by conversion factor 0.746 because we use 9.81 for water, kilonewtons per cubic meter. So we divide 0.746. 1 horsepower is 0.746 kilowatts. So horsepower dissipated is 12.22 horsepower.